Okay, good afternoon, all of you. So today we have a presentation on important techniques in solving problems in complex number. Actually, you see, complex number is a very important topic in for especially JEE mains and advanced in all India levels, any engineering exams. And complex number is not only a complex numbers, but it includes different types of geometry involving uh, different types of plane geometrical problems, and especially if you are talking about complex plane, Gaussian plane or Argand plane, so using that, so you have a very vast geometrical concepts needed for solving problems on complex number. So let's start with the problems. First problem: for any complex number z, the minimum value of mod z plus modulus of z minus 2i is. So for any complex number z, what is the minimum value of this? So first of all, you have to understand what is mod z and what is modulus of z minus 2i. Actually, represents modulus of z represents the distance of the complex number from the origin. Okay, so modulus of z represents the distance of the complex number from origin. So modulus of z is root over x square plus y square, and obviously the same representation for modulus of z minus 2i. So now we can write, in this case, we can write modulus of 2i equal to modulus of z plus 2i minus z. We can write this. Okay, so I'm writing 2i as z plus 2i minus z. So z minus z cancelled out, and using the inequations for complex number, we can write modulus of z plus modulus of 2i minus z. So this is the inequation between two complex numbers. If you have addition of two modulus of addition of two complex number or subtraction, we can write this inequation that modulus of z1 plus z2 less than equal to modulus of z1 plus modulus of z2. So here you have z, and 2i minus z plays the role for z2. Now what is the modulus of left? The modulus of left is modulus of 2i is 2, nothing but your 2. So 2 less than equal to mod z plus modulus of 2i minus z. So it's a very simple technique. You can use this technique in many problems. So the minimum value in this case of this expression, the expression means mod z plus mod z of z minus 2i is 2. That is the modulus. So the minimum value is 2. Okay, and it is attained for any z lying on the segment z equal to 0 and z equal to 2i. Actually mod z that implies equal to modulus of z minus 0, and mod z minus 2i and mod 2i minus z is same thing. So we can write z equal to 2i, the point. So it connects the mod z plus mod 2i minus z or z minus 2i, connects the points z equal to 0 and z equal to 2i, and it is attained for any z lying on the segment. Actually it represents a segment. This value represents a segment. Okay, so 2 is the minimum value. So your option is 3 or C. Let's go to the next problem. For all complex numbers z1 and z2 satisfying modulus of z1 equal to 12 and modulus of z2 minus 3i minus 4i equal to 5, the minimum value of modulus of z1 minus z2. First of all, what does it represented by z minus alpha equal to r? What does it represent? That is the question. So z minus alpha is a complex number, obviously. Z minus alpha equal to r represents a circle in the complex plane. Z minus alpha equal to R, modulus of Z minus alpha equal to R represents a circle in the complex plane, and the center is alpha and the radius is R. Alpha is the, that is in the complex plane or Gaussian plane or Argand plane. So mod Z minus alpha equal to R represents a circle. Similarly, if you are talking about modulus of Z1 equal to 12, that represents a circle with center 0 and radius 12. And Z2 minus 3 minus 4i equal to 5, that is also represents a circle with center at 3 comma 4 and radius 5. So now the minimum value of Z modulus of Z1. So let's solve the problem geometrically. So here is a diagram for you. This is in the Argand plane or complex plane. If this white space is your Argand plane or complex plane, then draw the diagram. So one of the diagram is Z equal to 12, mod Z equal to 12. So that represents the circle with center origin and radius 12. Okay. So this is the circle, suppose. Okay. This is the circle. Z equal to 12. So this is the origin and the radius is 12. So this point is 12 comma 0. Okay. In complex plane. And another circle is having, look at that, another circle Z equal Z2 3 comma 4 is the center and 5 is the radius. So what is your 3 square plus 4 square? Root over 3 square plus 4 square, that is also 5. Okay. So 3 comma 4 is the center and the circle passes through the, so this is your 3 comma 4 suppose. Okay. And this is the circle passes through the center 3 comma 4 0 0 origin. So this is the center, suppose 3 comma 4. This is the center, B is the center 3 comma 4 and the radius is 5. So this is the radius. This is radius is 5. Okay. Now Z1 represents any point on this circumference of the circle. Z1. Look at the diagram. Z1 represents any point on the circumference of the circle drawn in a black color, and Z2 represents any point on the circumference of the circle represented by blue color. So you have two circles on the Argand plane, one having the center origin and radius 12, another one having the center 3 comma 4 and radius 5, and Z2 is a point on the circumference of the circle. Clear? Now what does it represented by modulus of Z1 minus Z2? So Z1 minus Z2 actually represented the distance between the points Z1 and Z2. Modulus of Z1 minus Z2 represents the distance between the points Z complex numbers Z1 and Z2. So where it is minimum, that is the question. So the minimum will be along this diameter, along this line, along the, let me draw a straight one. Yeah, this line, this extend this line. Yeah, this line, this is your Z2 and this is your Z1. So along the diameter of the, so let's suppose the diameter of the smaller circle is OC and this is D. So this CD is the distance Z1 minus Z2 modulus of. So this distance, you can find many distances. You can find this is the distance. This is a ring, right? It's like a ring. It's like a ring. Look at the distances. I can shade the distances. These are the distances. But which one is the minimum? The question is which one is the minimum? You see, this is the minimum one. That means along the diameter, of the smaller, and that includes smaller circle and the larger circle, that includes. So along CD, how will you calculate CD? This total length OC is 10, diameter is 10, and what is your OD? OD is the radius of the larger circle, so that is 12. So your CD is nothing but your 12 minus 10, that is 2. So that minimum value of Z1 minus Z2 is 2. That is diagrammatically we can solve. So your answer is 2. Okay, everybody? The minimum value of modulus of Z1 minus Z2 is 2. That is. Okay. So we have solved geometrically. Let's come to the next problem. Problem number 3. If modulus of Z minus 25I less than equal to 15, then max of argument of Z minus minimum of argument of Z is. What are the answer? That is the question. This is very good problem. This is also we can solve geometrically. So what do you mean by argument of Z? Argument of Z is nothing but the angle subtended by the complex number in the anti-clockwise direction with the positive direction or parallel to the x-axis. Positive direction with the real axis. Real axis. So let's solve this one. Yeah. So argument, first of all, Z minus 25I equal to 15. What does it represent? So it represents a circle. It represents a circle actually, whose center is 25I, that is on the imaginary axis, and radius is 15. So your circle will be looks like this. This is the circle. This center is 25I and radius is 15. This is the circle. So let me draw here in the organ plane. So let's take real and imaginary axis. Okay. Now this is the circle. Suppose, yeah, this is the circle. So your center is 25I. Okay. 25I, that is on the imaginary axis, and your radius is 15. Okay, this is your 15. And what is the minimum and maximum value of the argument? That is the question. So you see, Z is a complex number on the circumference of the circle. It's moving like an electron. You can see here is the position of Z, here is the position of Z. So this may be the position of Z. Okay, so we can think about that. So Z is any point on the circumference of the circle. So what is the minimum and what is the maximum? So look at that. An argument of Z is a tangential. Argument of Z is tangential to the circle, tangent to the circle. Okay. So look at that. If I draw a tangent at this point, I will try to draw the tangent. So let me try to draw the, yeah, this is tangential, suppose. Okay, this is A point, this is A point, and similarly on the other side of the circle, you can draw the tangent. Other side, this is B point. Okay, and this is the center C. This is the center C. Okay, this is the center C. So join the center with the points A, B, C. Okay, so at A point, look at that. This is the theta argument or amplitude. So we have drawn a tangent. OA is the tangent at A and OB is the tangent at B. So OA is theta, suppose. This is the minimum value of the argument. If you take any position on the circumference of the circle, this tangential position, if you draw tangents on the circumference of the circle, this will be the minimum position. This is the rough diagram. I'm just giving you the idea. And B is the maximum position. In other position, it will be less than B. So B is the maximum value of the modulus. So at A, it gives you the minimum value of the argument. At B, it gives you the maximum value of the argument. Now this is the geometrical point of view. Now let us calculate. So if this is theta, this is tangent, so this is 90°, this is also 90°. Okay, so from triangle OAC, cos of, so this angle is pi by 2 minus theta, right? This angle is pi by 2 minus theta. So cos of pi by 2 minus theta is equal to OA over OC. Okay, OA over OC. So OA is nothing but your 20. How it is 20? Because you see, you can OC equal to, OC equal to 25 and OC equal to 25 and AC equal to 15, because the radius of the circle, and you know that center is at 25. So from the origin, the distance of the center is 25. So you can apply Pythagoras and get the value of OA. So OA is OA is 20 over OC is 25, 4 by 5. Got it? So that is the value of cos of pi by 2 minus theta. So cos of pi by 2 minus theta is 4 by 5. Okay, this is your, so your pi by 2 minus theta is cos inverse 4 by 5. Cos inverse 4 by 5. Pi by 2 minus theta is cos inverse 4 by 5. So you see this angle is this. Similarly, you can get COB is cos of, you have a pi by 2 minus. So this is the maximum, and these two angles are, this is symmetric. This is symmetric diagram. So you have similarly BOC is also cos inverse 4 by 5. So argument, so minimum of argument of Z minus, sorry, max of argument of Z minus minimum of argument of Z equal to argument at B equal to argument at B minus argument at A minus argument of A equal to 2 pi by 2 minus theta, twice pi by 2 minus theta, that is equal to 2 cos inverse 4 by 5, because already proved the angle pi by 2 minus theta is cos inverse 4 by 5. So that is the concept. So this will give you the concept of argument and as well as the minimum value and maximum value. So let's look at your options. Your options are 2 cos inverse 4 by 5. So option is B. This is your answer. Okay. Next, go to the problem number 4. The number of solutions of z cube plus z bar is equal to 0. How many solutions you have? This type of questions are also very important. Number of solutions. So first of all, you write this z cube plus z bar equal to, okay, take z bar to that side. So you have z cube equal to minus z bar, and taking modulus of z cube equal to modulus of z. Why? Because you see, modulus of z bar is modulus of z. Distance of z from the origin and distance of z bar from the origin is same. So that is why modulus of z bar is equal to, minus is absorbed by the modulus, equal to mod z. Okay, that's it. So if you solve this, you will get mod z squared minus 1, that is mod z minus 1 into mod z plus 1 equal to 0. So either you have z equal to 0, mod z equal to 1. These two are two cases, because mod z plus 1 can never be negative. Mod z plus 1 is greater than 0. This value is greater than 0. It cannot be negative. Mod z cannot be minus 1. So it is always positive. Mod z plus 1 is always positive. So only two possibilities you have. Either mod z equal to either z equal to 0, that is mod z equal to 0 implies z equal to 0, and mod z equal to 1. Two possibilities you have. So let's solve the two possibilities. So you have mod z equal to 0 implies only possible when z equal to 0. Z is 0 is one of the solution, and mod z equal to 1 implies z into z bar equal to 1. Mod z equal to 1 implies z equal to z into z bar equal to 1. So you have z bar equal to 1 by z, because mod z equal to 1 implies mod z square equal to 1. So that will give you z into z bar equal to 1. So z bar is 1 by z. Therefore, your equation, go to the equation z cube plus z bar equal to 0. Now replace your z bar by 1 by z. That will give you z cubed plus 1 by z equal to 0. So that will give you z to the power 4 plus 1 equal to 0. So you have four solutions of this equation. There are four solutions of this equation. Four roots, complex roots of this equation. So 4 and this 0, including 0, 5 solutions. So how many solutions you have? 5. So look at that, your option is 5. Okay, that is the solution of number of solutions of this equation. Next problem. So next is z1 and z2 be the nth roots of unity which subtends a right angle at the origin, then n must be of the form. What is the form of the n? 4k plus 1, 4k plus 2, 4k plus 3, and 4k. That we have to find out. So z1 and z2 be nth roots of unity. And you know that if z is a nth root of unity, you can write from De Moivre's second statement. De Moivre's second statement, you can write z equal to cos of 2k pi over n plus I sin 2k pi over n. That is from De Moivre's second statement, k equal to 0, 1, 2, etc. n minus 1. So there are n roots actually. Okay, this much you know from the second statement of De Moivre's theorem. So if z is a nth roots of unity, you can write cos 2k pi by n plus I sin 2k pi by n, where k has n values. Okay. Now, according to the question, nth roots of unity which subtends a right angle at the origin. Right angle at the origin. So you have 2k pi by n is pi by 2. Is pi by 2. So you see, you have the form n equal to 4k. This is one of the way for solving. This is done. Another way I will show you by rotation, applying rotation. So look at that. Z1, Z2 are at right angles. Okay. So now this, let us have the Argand plane. So your Z1 and Z2 will be like this. This is your Z1 and they are at right angles, right? This is your Z2. And you know that from the rotation theorem, if a complex number is rotated through an angle theta, then Z2 can be written as I e to the power theta. Okay. So Z2, this is 90 degree. So Z2 can be written as IZ1. What is the relationship between Z2 and Z1? Z2 equal to IZ1. Why? Because I has the modulus amplitude form. I can be represented as cos pi by 2 plus I sin pi by 2. Okay. So I am using Coni's theorem, that is rotation theorem. So it can be written as e to the power I pi by 2. Okay, e to the power I pi by 2. So that is nothing but your I actually. So I can be written as this, cos pi by 2 is 0, sin pi by 2 1. So this can be written as, so if a complex number is rotated through this angle, then it can be written as Z1 times e to the power I theta. If it is rotated by theta, then Z2 can be written as Z1 e to the power I theta. That is the rotation theorem. Okay, in this case you have IZ1. So Z2 to the power n equal to n because it's a nth roots, n equal to 1 because it's a nth roots of unity. So you can write Z1 I to the power n equal to 1. Okay, so you have I to the power n equal to 1. Why? Because Z1 to the power n is again 1 because Z1 is a nth roots of unity. So I to the power n will be satisfied by 4k, any number which is a multiple of 4, because I to the power 4 is 1, I to the power 8 is 1, I to the power 12 is 1, and so on. So the form is 4k. So there are two ways of solving this. Either you can do like this or you can apply rotation theorem. Okay, everybody. Next, I will go to quickly number 6. After that, I will after completing this presentation, I will take questions from my dear students. So have patience. I will answer all your queries. So the number of complex numbers satisfying, next question, mod z equal to 2 and mod z equal to modulus of z minus 1 is equal to how many? Number of complex. That means you need to solve. Now look at that again, mod z equal to 2 represents a circle whose center is 0 and radius is 2, and mod z equal to mod z minus 1. Actually, z minus alpha equal to mod z minus beta. What does it represent? It represents the bisector, perpendicular bisector of the line segment connecting alpha and beta. It represents actually mod z minus alpha equal to alpha and beta are complex number. So it represents the segment alpha and beta, and mod z minus alpha equal to mod z minus beta actually represent the bisector of the segment joining alpha and beta. Bisector of the segment joining alpha and beta, and this length is z minus alpha and this length is z minus beta. Okay, so it represents any point on this perpendicular line. This represents, this is the locus. Actually this represents the locus. So in this case you have mod z minus 0 equal to z minus 1. So it represents the bisector of the segment joining 0 and 1, joining 0 and so that is half, that is z equal to half. It represents the line z equal to half, it represents the line z equal to half. Let me draw here. So it represents the line, this is 0, z equal to 0, and this is suppose z equal to 1. So it represents the bisector connecting z equal to 0 and z equal to 1. This is so z, this is z equal to half in the complex plane. And another thing, mod z equal to 2. What is mod z equal to 2? Mod z equal to 2 is a circle, center at 0 and radius equal to 2. So it will be looks like this. It will be it will be bigger circle. Yeah, it will be look like this. Yeah. I have drawn a big circle actually. So how many points are there? So you're just increase the length of your segment, increase the length of your segment. Yeah, this is the segment. So it's intersect at 1 point, and here is also another point, 2 points. So actually z equal to half represents the bisector connecting 0 and 1, and z mod z equal to 2 is the bigger circle. So there are two with 2 as radius and center at 0. So there are two intersection points. So two solutions. So there are two solutions. Option is C. Option is C. Okay. So that's the concept of bisector and also the circle having radius and center. Next problem. Find the point of intersection of the curves argument of z minus 3i equal to 3 pi by 4 and argument of 2z plus 1 minus 2i equal to pi by 4. Argument of z minus 3i equal to 3 pi by 4. Now the question is, what do you mean by argument of z minus z naught? Z naught is a complex number equal to suppose theta. What do you mean by? Actually, this represents a ray. This represents a ray with, suppose this is the complex number z, z naught. This is the complex number z naught. So it represents the ray starting from z naught in the anti-clockwise direction. The angle makes with the positive real axis is theta. This is the argument. Actually, this is the representation. So argument of z minus z naught equal to theta is actually represents a ray starting at z naught but not including z naught and making an angle theta with the positive real axis. That is represented by argument of z minus z naught equal to theta. So argument of z minus 3i represents equal to 3 pi by 4 represents a ray starting at 3i and making an angle 3 pi by 4. So let me draw that. So let's have an Argand plane. Yeah. So this is your 3i. Suppose this is your 3i. So let's draw a line parallel to real axis. So it's your ray will be like this. This is the ray represented by argument of z minus 3i equal to 3 pi by 4 and making an angle 3 pi by 4 with the real axis. So this is the angle 3 pi by 4. Look at that. It makes with the parallel, that means it makes with the real axis, but that is not included. Z equal to 3i is not included in the locus except at 3i, 3 pi by 4. So this is the angle, this is the representation of the locus. Now what do you mean by the, what do you represent the argument of 2z plus 1 minus 2i? So you have to little bit do some calculation. So you can write argument of 2 into z plus half minus I equal to pi by 4. You can write this, and product of arguments is equal to argument of 2. You can write plus argument of this whole complex number equal to pi by 4. And you know that argument of 2 is 0. Argument of 2 is a real number. So there is no argument. So real point has argument 0. So this will be 0. So you have ultimately argument of 2 plus argument of z minus half plus I. So your complex number is minus half plus I equal to 3 pi by pi by 4 you have. So argument of 2 is 0. So you have final stage z minus of minus half plus I equal to pi by 4. That's it. That is the argument. This is the, so we'll represent the locus of this complex number. So let us point out. So minus half will be this side and plus I. So this is the point minus half I, not including that point. So the ray will start from here and it will be like this and makes an angle pi by 4. So this is the pi by 4 with the positive real axis. Okay. So you have two rays. One started with 3i but not including 3i and makes an angle 3 pi by 4. Another complex number at another ray at minus half comma 1 but not including that point, starting at that point and makes an angle pi by 4 with the positive real axis. So these two rays, and you see from the diagram Argand plane, there is no common intersection. So your intersection is 0. There is no solution, common in solution for this. So find the point of intersection of the curves. So no intersection, your answer will be no intersection. So this is very, very important concept, all of you. Okay, so we have two more problems for this presentation. Another one, just you have to read the question. Yeah. A man walks a distance 3 units from the origin towards the northeast direction 45 degree, and from there he walks a distance of 4 units toward the northwest direction to reach a point P. Then the position of P in the argon plane. You have to find the position in the argon plane. That means you have to complex points. So your diagram will be, let me have a diagram. So let's have a diagram here. Yeah. The man, once again, the man walks a distance 3 units from the origin towards the northeast direction. So let's start from the origin. So this is your origin in the argon plane O, and northeast direction 45 degree. So suppose this is the position of the man, and that is A, suppose, and it is represented by Z1 is the complex number. Okay, 3 units from the origin. So this is 3, modulus is 3, modulus of Z1 is 3, and from there he walks a distance of 4 units toward the northwest. So from here, okay, from here you can draw like this. Yeah, this is perpendicular. Okay, so this is the position Z2 is the complex number, and P is the position of the complex number. Let us connect OP. Sorry, it's very difficult to draw with a mouse. Yeah, so it's OP is the complex number Z2. Okay, OP is the position, new position. So this is, you have to find out this angle. Okay, this is 3, this is pi by 4. Just read, he walks a distance of 4 toward the northwest direction to reach a point P, the position of P in the argon plane. You have to find out the position of P in the argon plane. Okay, so this is 90 degree. Okay, this is 90 degree. Now this is pi by 4. Now what is your OP? Your OP is, direction OP is OA plus AP. Rotating OA by an angle 45 degree in anti-clockwise direction to get OP. Got it? So this is your, so you are rotating OA by an angle 45 degree in anti-clockwise direction to get OP. We have, so this is Z2, this is Z1. So we have, by your calculation, by using rotation theorem, Z2 minus 0, because the origin, the ratio connecting Z1 minus 0 equal to modulus of Z2 by modulus of Z1, their length. And what is the angle between them? The angle, suppose theta. What is the angle between them? Theta. This is 3, this is 4. So how will you get theta? So tan theta is perpendicular. This is perpendicular actually. This is 90 degree. This is 90 degree. So perpendicular per base. So 4 by 3. 4 by 3 you can calculate. So you can calculate sine theta and cos theta from here. So your sine theta will be 4 by 5 and cos theta will be 3 by 5. Okay. So how will you get tan theta? From this triangle AOP. AOP. Okay. From this triangle. And you can write Z2 minus 0. So this triangle you can write Z2 minus 0, origin is 0 actually. So Z2 minus 0, Z1 minus 0 equal to, so modulus of Z2 by modulus of Z1 into e to the power I theta, correct, into e to the power I theta. Okay, because any complex number can be written as z equal to modulus of z into e to the power I theta. That you can write. Any complex number can be written as a complex form, polar form. So I'm writing this. So the modulus of z2 is, I don't know modulus of z2. You have to find out z2. 5. Modulus of z2 is 5. So it is 5 by 3 into cos theta plus I sin theta. Okay. So that is z2 by over z1. And you know the values of cos theta and sin theta. You can easily get z2 in terms of complex number, polar form or Argand plane. So that will be equal to 3 plus 4i, because your z1 is 3 e to the power I pi by 4, 3 e to the power I pi by 4, that is the representation of z1, 3 e to the power I pi by 4. So you can calculate. So this will be e to the power I pi by 4. That is your z2 by using Coni's theorem and the rotation. Okay. So that is the representation of z2. So let's come to the last problem, everybody. Today's lecture, this is the last problem. After that, I will take questions from you. So what is the area of the triangle in the Argand plane formed by the complex number z, iz and z plus iz? So let's have a complex plane first. This is the complex plane or Argand plane. So you have a complex number z and iz. You know that iz is perpendicular if you rotate z in the anti-clockwise direction with 90-degree rotation. So that will be iz. This is your z, and z plus iz if you complete the parallelogram. So the diagonal of the parallelogram will give you z plus iz. The tip of the diagonal z plus iz. So complete the triangle O A. This is your B and this is your C. Okay. Now triangle, area of the triangle OAC is equal to the area of the triangle. If you apply OAC, that will be equal to area of the triangle ABC. Area of the triangle ABC. Okay, it's the same. If you are talking about area of the triangle ABC, because it is a parallelogram and a diagonal gives you two equal triangle. So that is equal to, so what is the area of the triangle OAC? Half base. What is your base? This is 90-degree. So your base is OA. And what is your height? Height is your OC. Correct? So half, what is your OA? Mod Z. What is your OC? Mod IZ. So that will give you mod Z square. So half mod Z square is the area of the triangle. Is the area of the triangle. You can use the theorem for area of the triangle, that is a half of imaginary of that formula also. So I'm not talking about that formula, that is more complicated to remember. It's better to use geometrical knowledge to draw the diagram and calculate. So that will give you a simple techniques. So look at that in my lecture today. Actually, I focus in the mainly how will you solve the geometrically, how will you solve all the problems using Argand plane and Gaussian plane geometrically. Geometrical concept is very important for solving problems in complex number. So thank you all of you for your patience.